Welcome back to our Spark Learning session. Today we'll be talking about logistic regression. We'll use for this session a documentation example where we'll run through the examples provided and see how you can do that. For starters, let's start by initializing Spark and calling the libraries that we need for our project. We'll do it import. Let me just copy and paste whatever we need such that I don't have to type everything all over. Let me run this to initialize the Spark environment. It's running now. As it runs, let me type some libraries that we need to import for our project. From PySpark .ml dot classification import and it's going to be logistic regression. From PySpark ML classification and logistic regression. Second library we need to import is from PySpark .ml .evaluation import binary classification evaluator comma multi classification evaluator. These are libraries we need for our project. Now let's load some data that we require for this for our project. That would be loading training data. And let's call it my data for namesake purpose, and spark read dot format. Let us do it's a this format is a libsvm format. It's a special kind of format that's not widely used, but it's used in the examples because it is convenient. Let me run this again so that we import library that we need, and let's add the num features. The number of features in this data set we need to add is 692 features. We have that's a big data set, 692 features. Dot load dot simple sample libsvm. The name of the file is sample libsvm.txt. I can just copy and paste it. Okay, I cannot. So let me rename it and copy and paste this so that I don't have to type it again. Let me rename this and copy and paste it. .txt. Running it now, and it's running. In the meantime, let me start typing another command, data.show. We want to see what's inside the data we just loaded. Next step, we need to create a model. This is the data set we have. It has mainly two columns. One is a label, and second is the features with the index. 692 features, 93 features, and all the features data there. Now next step is to create a model. We need to create a model. How do we do this? Let me show you. Let me type create the model, my log reg. Let's name this model as my log reg model. That is my logarithmic regression model. And let's initialize logistic regression library. We just imported earlier. Second step is to fit this model on a given data set. Fit log reg model, fit the model. Second step is to fit the model. That's exactly what we're gonna do. Fitted log reg model. Dot fit my data. Let's run this as well. And third step, we're going to look at a summary of the model. What is it? Once we fit the model, we look at a summary of the model or overview, like what does model, well, some statistics about the model. Let's see what does it show. Log summary. Log summary. That's the we'll assign that to a data frame. Next, what we need to do is we need to see inside log summary. We need to look at the predictions information of this model. What kind of prediction this model do? And for that, we need to look at log summary dot predictions. This has information that we need. It's a data frame. Now, this data frame has lots of information, that is label, features, raw prediction, probability, prediction double. Raw prediction are related. That is, raw is a non-processed prediction, while prediction is a process prediction. And there's some algorithm that it uses to process those. Moving on, we need to see inside what is inside data frame, and for that, I will type predictions dot show. Let's move on. Let's move on what we have here. So we have this data set with label, features, raw predictions, probability, and predictions. Now, next step is to just take a look inside raw prediction and take a closer look at that and see what we see inside that. Log summary dot predictions and see what is inside that. How can we see that? We can see that by typing this command. We'll take this data set and select the column that we want to take a closer look at and type it here. And next step we'll write a show. Give me show and type 5 by 100. Show me 5 rows and up to 100 character length. It is giving error. Why is that? I have written the spelling of the select wrong, so that's why it is giving me error. Let me fix it and start it again. There you go. We have our what we need. Next step, we need to do some modification in our data set. Remember how when we generate our data set, we did not split data set into train and test data? Generally, that's not correct way to do it. The correct way to do it is to split data set into train and test data, and that's exactly what we're going to do now. Let's do that. For that, let's create two variables that's going to hold the train and test data from our data set, and we're going to split it to my data, a random split. It has to be random. It's not a normal split, it's a random split, and it's going to be 70% will be train data and 30% will be test data, test data. And let's run it and let's see what we get. It runs successfully. Now, next step is to create a new model. Let's name it final model. It's a new model, new logistic regression model, and let's name it final model. Logistic regression model. Same as before, but this is a new model. That means final model. Now we have to train this data on a new data set called LR train. Let me put a new cell so that we can train this new model on a new data set called LR train. Fit final is going to be a new fitted model. Final model, we're going to train this final model on a new data set called fit LR train. Let's run this. It is giving error. Why is that? Fit final is not defined. Final model is not defined. I have made a spelling mistake here. So let me correct that and run it again. It's giving error again. Why is that? Because I haven't ran this final model. That's why it is giving me error. Now it won't give me error. Let's try it again. Now it works. Next step, what we need to do is we need to evaluate this model, the fitted model, into a different data set called LR test. For that, we'll create a variable that holds the data frame from this evaluation into labels, into prediction labels, and we'll evaluate finally on test data. Evaluate LR test. Let's do that. Let's see what we get for that one. Now we have run this thing. Let's see inside the data frame and let's see what inside it do show. And this will show what this variable holds, what this data frame holds. We forgot to look for predictions, which has the data frame, what we need. And let's run it again and let's see what we get. Yes, we have what we need now. We have labels, features, raw prediction, reliability, and prediction. Next step, we are going to use a function called evaluators. Evaluator is a very important part of our pipeline when working with machine learning. More information can be found in Spark Apache docs. Let's not go into the website and let's continue with our exercises. We have imported evaluators earlier in our project right here. Now let's initialize the binary class evaluator. It's going to be a binary class, not multi-class. For binary class, we'll name it as B eval and ROC. ROC is a default measure from this evaluator. It doesn't have any other measures that it returns, metrics it returns. So we'll just name it binary eval ROC, return receiving operating curve. That's the name of this evaluator. And next step, we'll see what is the ROC from the evaluator holds. Now this has been evaluated. Now we'll see the result of this evaluation. And we'll put that into ROC result. Let's recall our binary eval ROC and dot evaluate, and we'll evaluate our data set that holds the predictions, and that would be this data frame. And let's run it and get the ROC result. Now our next step is to look at inside the what's the ROC result hold. We'll just simply copy and paste it here and run it, and it's 1. This is really interesting because 1 is a situation where the our logistic regression perfectly classified into give us a perfect result. That means there are no any errors in when classifying the labels, and this is really good. But in real world, it will not be this good because there will be lots of messy data in real world. Since this is example data, that's why it is this good. Next, we need to work with the multi-class evaluator or multi-class evaluator, And for that, we'll just initialize that. Our multi-class evaluator, m evaluator, that produces the accuracy. We are interested in F1 accuracy, and we'll just look for that. F1 accuracy, we'll name it as such, and initialize the multi-class evaluator at this point with the required columns. Prediction column will be prediction from our data set. We have prediction here. We'll use this column to that index that column here. Secondly, label column will be label, and metric name will be accuracy. That's what we are interested in. Metric name will be accuracy. Let's define our class evaluator. Prediction column is not defined. We made a mistake. Prediction column. Now it should work. Happens sometime. Now we need to use our evaluator and target that to our dataset from our model, and we'll name this evaluation as accuracy. M eval will be our evaluation model, where it will evaluate the resulting dataset from our model. It can be prediction and labels dot prediction. Name this. I think made mistake here. It should be just accuracy, not F1 accuracy. Let's run that. And now let's see what we have for our accuracy result. 1. It is perfectly accurate. That's interesting, isn't it? Now, next, we need to do some other metrics beside accuracy. Let's do F1 metric. For that, let's name this as M eval dot F1 equal to, let's copy and paste this and just change metric name into from accuracy to F1. Let's F1 hold the result from our evaluation. And let's see what's inside F1. 1, perfectly perfect. That's all for today. Let me quickly summarize what we learned today. We learned about logistic regression in Spark. Initially, we started with initializing the required libraries, and then we imported a dataset. Secondly, we created a model, logistic regression model, and then we fitted the model on our dataset. Then we took the summary from that model, and summary had a data frame called predictions, and we look at that prediction contained there are many columns, and we use that prediction data frame to do some evaluation using different evaluators that is provided by PySpark. One was a binary classification evaluator, and second was multi-classification evaluator. And we use those evaluators to evaluate our prediction from the model we just generated. Thank you so much. I will see you in next learning session.